NASA has a plan to build a base on the Moon before sending people to Mars. This way, the journey to Mars will be shorter. SpaceX founder Elon Musk wants to lead the race to Mars. European and Russian space agencies also talk about sending humans to Mars. But once people land on Mars, the question is how they will survive because, unlike Earth, Mars doesn't have oxygen. NASA has figured out a way to produce oxygen on Mars, but it's different from the way the International Space Station, ISS, makes oxygen. There are many reasons humans want to live on Mars. Scientific exploration and curiosity are part of it. But there is also a fear that if a disaster happens on Earth, humans might not survive, just as dinosaurs were wiped out 65 million years ago. Climate change is another example of a potential threat. Elon Musk originally planned to start colonizing Mars in 2026, but has now adjusted this target to 2029.
You've slightly put back the expected date to put the first human on Mars till 2029, I want to say.
Yeah, I mean, let's see. I mean, we have built a production system for Starship, so we're making a lot of ships and boosters.
Meanwhile, other agencies have set a goal to land people on Mars by 2030. But the real question is not who will reach Mars first, but how humans will survive there. Mars shares some properties with Earth. For example, a day on Mars is only 39 minutes longer than a day on Earth. Mars also has different seasons, ice caps at the poles, and a thin atmosphere. However, the major problem is the lack of oxygen for humans to breathe. So, how will we produce enough oxygen to sustain a colony on Mars? One approach could be inspired by the ISS, which has been operating for 25 years in the harsh environment of space. The ISS provides oxygen and fresh water for the astronauts on board. It uses two systems: the Water Reclamation System, WRS, and the Oxygen Generation System, OGS. WRS purifies water from sources like urine and sweat, making it safe to drink. The OGS then takes a small amount of water and splits it into oxygen and hydrogen through a process called electrolysis. The oxygen is used for breathing, while the hydrogen, which is highly flammable, is combined with carbon dioxide to produce more water and methane gas. Methane, though valuable on Earth, is released into space from the ISS because oxygen required to burn methane is too precious to use. The ISS, however, relies on regular resupply missions to Earth for water and oxygen, as even the efficient systems experience some losses. But resupply missions to Mars, which is 225 million kilometers away, are not practical. In 2021, NASA sent the Perseverance rover to Mars with an experimental device called MOXIE, Mars Oxygen In Situ Resource Utilization Experiment, to produce oxygen directly from the carbon dioxide in Mars's atmosphere. MOXIE compresses and heats carbon dioxide to 800 degrees Celsius, breaking it down into oxygen and carbon monoxide. This process requires a lot of energy, so MOXIE is only run occasionally. So far, it has produced 122 grams of oxygen, enough for one person to breathe for 35 hours. Scaling up MOXIE to produce more oxygen for a full colony would require a much larger device and a dedicated power plant. Scientists are also working on future technologies to break down carbon dioxide at lower temperatures by creating vibrations in the molecule instead of heating it. This method has been tested in labs, but cannot be done on Earth due to high atmospheric pressure and temperature, making Mars an ideal environment. Our goal is to create a self-sufficient oxygen production system on Mars, independent of Earth. Unlike the ISS, which is just 400 kilometers from Earth and can be resupplied, a Mars colony would face challenges if its oxygen generation system failed, as there would be no quick way back to Earth or refueling options. Don't forget, to like and share.